So Norman, I am not good with making videos, but I wanted to show you here as best I can the piece I'm sending you. Actually, I'm sending you two. They're the same. The lead screw looks like the usable length is 5 inches. Hopefully that's enough, or you should be able to modify. The whole unit is probably about 6 inches, but there's a rather large half nut assembly here. Let me show you this as best I can with one hand. So obviously the lead screw, the half nut is in this piece here. You just pull up as in depress, and hard for me to do with one hand here, so I apologize. We're going to spin this around so I can get some leverage. You would pull this out and just releases the half nut and move it back or to wherever you want to start it. The motor is a Faulhaber gear motor. This is a 12-volt motor. The numbers there, the 12S123, 12 stands for 12 volts. The 123, I believe, denotes the encoder that's on here, or maybe the 1624. It's been maybe 15 years since I did anything with these, so I'm sorry, I don't remember. But works very well just as a straight DC motor. You can see on the end, this disc has a magnet and a little reed switch. I've never played with that, but I'm assuming as the magnet rotates at a certain point, it must engage the switch and disengage. So if you needed a counter for a rotation, you should be able to get one click per rotation. Also, 2 of the wires go to an encoder that's built into the motor that likewise you should be able to read the speed and with software then be able to control the motor very precisely if needed. For what you're doing, you probably just run it as a straight DC motor. I don't understand the electronics that are on here, other than they certainly are a power supply, or the voltage regulator I would say here, and the speed control circuitry. So with that said, I'm going to try to balance this enough to show you the motor running. So I'm going to use a 9-volt motor just because it's simpler. And we are going to pause for a moment.